Hello, this video is on transforming data, which is the effect of constant changes on data, as shown here in the syllabus. The formula for the interquartile range is given on page 9 of your formula booklet. If you add or subtract a constant amount to every value in a data set, you will cause the average to change by that same amount. So the data will either shift to the right or shift to the left. This transformation of the data will not affect the spread of the data, however. Adding a constant k to every data value will change the mean, the median, and the mode by k, but it will not change the range, the interquartile range, or the standard deviation. For the data set shown in the example, enter in the data into the calculator. So that's 3, 4, 6, 9, 10, 15, 17, another 17, and an 18. And then performing a calculation of one variable statistics gives the following results. The mean, x bar, is 11, the median is 10, and the mode is 17. The range, which is the maximum value, 18, minus the minimum value, 3, is 15. The interquartile range, which is the upper quartile, Q3, that's 17, minus the lower quartile, Q1, which is 5, is equal to 12, and the standard deviation, sigma x, is 5.58, correct to 3 significant figures. Adding 3 to each data value gives the new data set shown here. Entering this data set into the calculator, so that's 6, 7, 9, 12, 13, 18, 20, another 20, and a 21, and again performing calculation of one variable statistics gives the following results. We see that the mean is now 14, the median now 13, and the mode now 20. However, the range, which is the maximum value of 21, take away the minimum value of 6, is still equal to 15. And the interquartile range, which is upper quartile of 20 minus lower quartile of 8, is still equal to 12. And the standard deviation, sigma x, is still 5.58, correct to 3 significant figures. So adding 3 to each data value gives a new data set with a mean, median, and mode all increased by 3, but a range, an interquartile range, and a standard deviation which are unchanged. If you multiply or divide every value in a data set by a constant factor, you will cause the average to change by that same factor. So the data will either be stretched further apart or squashed closer together. This time, the transformation of the data will affect the spread of the data too. Multiplying every data value by a positive constant k will multiply the mean, the median, and the mode by k, and will also multiply the range, the interquartile range, and the standard deviation by k. In the example, returning to the original data set, we had the following statistics: a mean of 11, a median of 10, and a mode of 17, a range of 15, an interquartile range of 12, and a standard deviation of 5.58, correct to 3 significant figures. Multiplying each of these data values by 3 gives the new data set shown here. Entering this data set into the calculator, so that's 9, 12, 18, 27, 30, 45, 51, another 51, and a 54. And performing a calculation of one variable statistics gives the following results. The mean of this new data set is 33, the median is 30, and the mode is 51. The range, which is 54 minus 9, is equal to 45, and the interquartile range, which is 51 minus 15, is equal to 36, and the standard deviation is equal to 16.7, correct to 3 significant figures. Multiplying each data value by 3 gives a new data set in which the averages, the mean, the median, and the mode, are 3 times bigger than the averages of the original data set, and the measures of spread, the range, the interquartile range, and the standard deviation, are also 3 times bigger than the measures of spread of the original data set. In this question, the mean of a set of data is 12 and the standard deviation is 15. If 100 is then added to every data value, we're asked to find the new mean and the new standard deviation. Adding will alter the averages. Adding 100 to every data value will increase the mean by 100. So the new mean is equal to 112, as shown. Adding will not alter the spread. So adding 100 to every data value will not affect the standard deviation. So the standard deviation remains unchanged, as shown. So the new mean is 112 and the new standard deviation is 15. In this question, the median of a set of data is 2.4 and the interquartile range is 3.6. If every data item is halved, we're asked to find the new median and the new interquartile range. Halving, or dividing by 2, will alter the averages. So halving every data value will halve the median. So the new median is 1.2, as shown. Halving, or divided by 2, will also alter the spread. So halving every data value will halve the interquartile range. So the new interquartile range is 1.8, as shown. So the new median is 1.2 and the new interquartile range is 1.8. In part A of this question, we're asked to find the mean, the median, the interquartile range, and the standard deviation of the test scores. Entering the data into the calculator and performing a calculation of one variable statistics gives the following results. The mean score is 85.2 and the median score is 87. The interquartile range, using the formula Q3 minus Q1, is equal to 37.5, and the standard deviation is equal to 17.9, correct to 3 significant figures. In part B, the scores must be scaled down to be out of 40 instead of 120. So to scale the numbers down to out of 40, we need to divide by 3. Dividing by 3 will alter the averages and the spread. So the median, the interquartile range, the mean, and the standard deviation will all be 1/3 of their original values. Dividing the mean by 3 gives 28.4. Dividing the median by 3 gives 29. Dividing the interquartile range by 3 gives 12.5. And dividing the standard deviation by 3 gives 5.95, correct to 3 significant figures. So the mean of the scaled scores is 28.4, the median is 29, the interquartile range 12.5, and the standard deviation 5.95. Correct to 3 significant figures.